Hey, this is Mrs. Razor, and we're going to be looking at the first section of Chapter 1 today. Please follow along on your note page, which looks like this that I have on the screen. I do have to warn you ahead of time, the program that I'm using to record this lesson only allows me to record 15 minutes at a time. So if I go over 15 minutes, I may have to make a second part to this. So I just want you to be aware. This is part 1 if we have to go into a second video. The top of your note sheet gives you some history on geometry and the father of geometry, so please read that on your own. But first we are going to talk about mathematical systems. The vocabulary and concepts used to develop all mathematical systems, algebra, geometry, trigonometry, calculus, all of it, are organized into 4 basic categories. Vocabulary terms are filed or used as either undefined terms or defined terms, which kind of doesn't make a lot of sense at first because you think, well, if I'm going to write a definition for something, then how can it be undefined? And we'll talk about that. Mathematical concepts are filed as either postulates or theorems. We are developing a mathematical system, geometry, which presumes an understanding of algebra, so our mathematical system will also include algebraic properties. So here are 5 components of our mathematical system. The first of which is an undefined term. Some basic terms cannot be defined without using circular reasoning, which means it comes back onto itself. There are only 3 undefined terms in geometry: point, line, and plane, which, oddly enough, are the 3 things that the rest of geometry is built upon. Defined terms would be every other term introduced into our geometric system, and it must be carefully defined. There is something called postulates and theorems. There is a difference. A postulate is some of the mathematical concepts we will introduce into our geometry system. They will be accepted as true without proof. You might also hear the word axiom, which is an older term used for postulates. Theorems are all the other concepts, facts, formulas, or properties that must be proven true using deductive reasoning before using them. And then algebraic properties are all of the properties learned in algebra, which will be entered into our system. And here's the way that I like to think about it. If you think about a football game, the terms in geometry would be like the equipment. The terms would be like the football and the goalposts. The postulates and theorems are like the rules of the game. They tell us how we can play the game and how we can use the equipment. So if this terminology is kind of confusing for you, think of, again, as the undefined and the defined terms as our equipment for the game of geometry, and our postulates, theorems, and algebraic properties as our rules for playing the game. Let's take a look at those undefined terms. Even though we are not going to enter a formal definition of the 3 undefined terms, we must all have the same understanding so we can describe what is meant by these terms, as well as how we will represent them in drawings and how we will name them. We have to all be able to name them the same way, otherwise we wouldn't be able to use them and we would get confused. A point is one of those undefined terms in geometry. It names a location and has no size. And that's what I'm talking about right there. How can we have a definition if it's undefined? Well, how can something exist without having a size? We still talk about the location and we still represent the location even though technically it doesn't have a size. So we will represent a point as a dot. We will name this using a capital letter. So I can name this point as point A. I can also just name it without using the word point and call it A by itself. If you ever just see a capital letter noted in geometry, it represents a point. Our next term is the line. It's an undefined term again in geometry, and it's a straight path that has no thickness and extends forever. Again, that's where the undefined part comes from. For something to exist but have no thickness, and then this idea of something going on forever, that's not something that our minds can really fathom. However, we can represent it with a picture. And the way that we represent this picture is with a straight path. I'm going to use my little cheat tools here. Use my straight path And then to show that it goes on forever and ever, we will represent that with arrows. In order to name a line, we can do it one of two ways. We can either use a small script letter, we'll see L pretty often, or you can use 2 points on the line. So let's put points A, B, and C on our line. There are a couple of ways I can name this. I could just name it line L using the script letter, or I could pick any of these 2 points on the line, say AB, but then I have to use the line symbol above it. And the line symbol also has 2 arrows. I could also name it BA. The order doesn't matter. Or I could use point C and maybe call this line AC. There are many options, but those are all appropriate ways. Use 2 points on the line with the line symbol above it, including 2 arrows. The plane is a flat surface that has no thickness and extends forever. And I'm sure you can guess it, that undefined part, again, is that it has no thickness and it extends forever. Something that our minds can't really fathom, but it still represents a location, and so we will define it here. So in order to draw a plane, most of the time you're going to see it in the shape of a parallelogram. So if you can sketch a parallelogram here, you might see other polygons. You might see a triangle. You might see a square. Those can be representative of planes as well, as long as they are flat surfaces. I'm going to put 3 points on this plane. We'll name them A, B, and C again. Then I'm also going to put something that's called a script letter. A script letter is like a cursive letter. I'll use the cursive letter R. So if I'm given a script letter such as this R, then I can just name this plane plane R. If there's no script letter given, don't add it to the picture. Only use it if it's there. If I'm going to use the points, then I have to use 3 non-collinear points. Something that we will talk about is what the word collinear means. Collinear means to have 3 points on the same line. Up here, A, B, and C are collinear. They're all on the same line. A, B, and C are not all on a line together. So I can call this plane A, B, C. No commas. Just like if I were writing my name, R-A-Z-O-R, I wouldn't put commas in between them. I'm not going to put commas in between the name of a plane either. You could also switch the order around of those letters, so all 3 of these names would be appropriate names for this plane, using the 3 non-collinear points. Moving on to defined terms. Some defined terms in geometry, if you look down your page there. A space is a set of all points. We can't even have any of these figures unless we have a space to put them in and the points inside that space to use. The first term that we can draw here is called a segment, and you already have a picture of it on your sheet. A segment is a part, otherwise known as a subset, of a line that begins at one point and ends at another, and contains all the points in between them. Since points don't have a size, there are actually an infinite amount of points between A and B. We will use A and B, which are called the endpoints, because they're at the ends of the segment. In order to name the segment, we would use the points at the beginning and the end, and our symbol for segment looks like this. Very similar to what the symbol for line looks like, but no arrows this time, because a segment has a beginning and an end and won't go on forever. Please note, you could also write the segment as BA as well. The order does not matter. Moving on, we have a ray next. A ray is a part of a line that starts at a point. Remember, that's called an endpoint. So in this picture, A is an endpoint and extends infinitely in one direction, and that one direction is represented by the arrow. The best way to name a ray is to list the endpoint first, then the point in which it goes through, and then when we draw the ray symbol, we draw the arrow going in the same direction as the point that it's going through. So from this name, you can tell that my ray started at A but went through B. Again, here are two terms that you need to be aware of. Collinear, see how it has the word line in it. Our points, segments, or rays are collinear if they exist on the same line. So up here in our ray picture, points A and B are collinear. There's also such a thing as non-collinear. And I'm sure you can guess it when we put the non in front of it. That means to not be collinear. So if I go back up to my picture of a ray and I put point C over here, point C is not on the same ray as A and B. So those 3 points, A, B, and C, would be non-collinear. There's also the term coplanar. It's got the beginning of the word plane in it, but it means for geometric figures that lie on the same plane. So points that are on the same plane, lines that are on the same plane, all on the flat surface, those would be coplanar. And then again, we have the word non-coplanar, which means some of our objects lie on one plane and our other objects lie on another. Opposite rays are two collinear rays with the same endpoint, but no other common points. So you'll notice that we have the word collinear here. Collinear means that we actually form a line. So I'm going to draw a ray going in one direction. We'll have it start at point A here and go through point B. But in order for them to be opposite rays, I will use that same endpoint A, but travel in the exact opposite direction. And when I travel in the exact opposite direction, I actually have a line that forms. I started with ray AB, which I could name like this, AB, with the ray symbol on top. But I also have in the other direction ray AC. So AC with the ray symbol on top. Notice that even though ray AC is pointing to the left in the picture, we still name it, starting with the endpoint, going through C, and the arrow still travels to the right. That's just the notation for ray, no matter what direction it's going in. So those are the pieces of equipment that we'll be using in geometry. And now we're going to cover the postulates. I am running out of time on this part, so I'm going to go ahead and stop this part of the video, and then I will start recording part 2. We just need to go through the postulates and then we'll be done. I expect it to be pretty short. So at this point, I would like you to now go to the link for part 2 of the notes and finish up the notes.